All right, what's up, everybody? Hutch here, and we're going to continue our practice with the Pythagorean theorem, mod 12, part 2 4. Last time we finished up number 3, you had to figure out the distance from the playground to the store. So you can check your work here. We solved that the distance is about 4 2/10 miles. Okay, so she would have to walk 4.2 tenths of a mile. We're going to move on to number 4 now, and so you can see these ordered pairs. Okay, I guess my recommendation to you with this would be you want to, one of the strategies for solving word problems and things like that is to draw a picture. Okay, so I can see positives and negatives in my ordered pair. So I'm going to go ahead and just draw a little sketch of a coordinate grid. Okay, something like this. I can see that I go all the way down to, if I look at the x-axis, so remember if I label these xy, 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 my biggest x is only 2.25. My smallest goes down to negative 6.5. So let's just go ahead and put some tick marks here. If I go 1, 2, 3, that's as far as I really need to go on that side. 1, 2, 3, 4, 5, 6.5. So I'll go to 7 on this side. If we look at our y's, we go down all the way to negative 10. So I'm going to have to go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So I'm just doing a little sketch here. Here's my x, here's my y, so that I can plot these points and sort of see what's going on. So I can see this right triangle. Okay, so let's go ahead and plot this. My first one is negative 6.5, so I'm going to go left on the x. Remember, we always crawl before we learn to stand, or fall in that sense, I guess. So negative 6, so 1, 2, 3, 4, 5, 6.5, and then down 3.5. So 1, 2, 3.5. So we have a point right about there. Let's do the next one here. We're going over 2.5 and down 3.5. Okay. So I noticed that my y's were the same on that one. Okay. So my x's were what was changing. So my y's, this is going to be going straight across. Okay, let's get our third point, though, before we start drawing lines. Okay, this one's over 2.25, so that's the same. And then it just goes down really far, all the way to that negative 10. Okay, so I know that those are on the same point. So now I can sort of sketch out my triangle here the best I can. I can see the right, where the right angle is. Okay, and so there we go. Okay, I've created my triangle with those ordered pairs, okay, and that really is going to help me out. So there's my right angle, and remember, we can't count diagonals. All we can count is the straight sides, okay? So I have a couple ways of doing this, okay? If I want to know, let's see, this ordered pair, okay, if I'm just looking at the x-axis, remember, this is 2.25 on the x. And where's my other one on the x? It goes all the way to negative 6.5. Okay, so I think to find that distance, instead of swooping or things like that, I just want to do some subtraction. Okay, so to find that distance, I'm just going to do 2.25 and subtract the negative 6.5. Okay, and that's how we find difference, right? And I know that I can KFC that, and it's going to tell me my total distance. Okay, so 6.5 plus 2.25, 6, 7, 8. And so then we have 8.75. Okay, anything with decimals, it's always good to just double check. So 2.5 minus a negative 6.5, same thing, I just want you to see, is 8.75. So this distance, let's pick a different color. This distance here is 8.75. And it doesn't say anything, so it's just units, okay? So then what's the distance of my other straight side? Well, that's a we have to look at where we're at on the y-axis now. So now I don't care about this number at all, okay? So you have to realize what's going on here. I want to know from here down to here on this axis, okay? So that's something to be aware of now, a little bit different. So how far down am I? Okay, well, I am 3.5 down. So I'm at a negative 3.5, okay? And then how far did I go down? I went down to negative 10, okay? And so you can see my two y's, okay, for that one, okay? And how do I find the difference? Well, we just subtract them, right? So negative 10 minus a negative 3.5, okay? And that's going to tell us the difference, okay? If I KFC that, really we're just doing negative 10 plus 3.5, okay? So we can go ahead and type that in, okay? Negative 10 minus a negative 3.5 is the same thing. And so we have negative 6.5, okay? So think about that, though. Can we really have a distance that is negative 6.5? No, we can't. A distance is always going to be a positive amount, right? So that's why when we do this, really we're taking the absolute value of these, okay? And so it's going to be a positive answer no matter what, okay? So really this distance is a distance of 6.5 and a distance of 8.75 like I had. Okay, so just be aware of what's going on with that kind of thing. So this distance is a distance of 6.5. Now we can go ahead and figure out what our third side is. Okay, so we have A, B, and C, and we can go ahead and solve. Okay, so let's go ahead and figure this out. So A squared plus B squared equals C squared. Okay, and we can go ahead and figure this out together. Okay, so 6.5 squared is that. 8.75 squared is that. Okay, and I do want you to show the layers because then we can see where we maybe made a mistake. If the decimal does stop, let's go ahead and write the whole decimal so we're as accurate as possible. Okay, so we have 42.25 plus 76.5625. I don't want to round anything right now. I want to be as accurate as possible. Let's go ahead and add those up. Okay, so I'm going to go ahead and just to save time do answer plus 42.25. Okay, so right now we're at 118.8125 equals C squared. How do I get rid of the squared? Well, we take the square root of both sides. That's going to cancel that out. And we're going to end up with our length for C. So how long is C? Well, let's go ahead and take the square root of that answer. Okay, so let's see if I can do this. Square root of the answer. Will that work? Yep, it will. Okay, so the square root of the answer, okay, and we're going to have to round this, is about 10.9, because then it goes 0, 0, 1, 1, 4, 6, 8. It looks like an irrational number. Okay, so we'll say about. Okay, so 10.9, and there we go. So that's what C is. Okay, and you can see you would never be able to count that on your own. You'd have to use the Pythagorean theorem. So let's go ahead and do some other word problems. It does say draw a picture to represent the situation, and then round everything to the nearest tenth. You must show work. Okay, so this will be some good practice ones for you. It says the bottom of an 18-foot ladder is 5 feet from the side of the house. Okay, so it's good to draw a little sketch here. Okay, so I'm just going to draw like super easy house here. Okay, so there's my beautiful house. The door and such like that. Okay, there we go. Good enough, right? Okay, so the bottom of a 18-foot ladder is 5 feet from the side of the house. Okay, so we're going to go 5 feet out and this is where the bottom of my ladder is, and it goes up 18 feet up to the house. Okay, so here's the ladder. Okay, so you got to understand what's going on there. They're actually letting you know that the ladder itself is 18 feet. So there's my ladder, right? Okay, and it says find the distance from the top of the ladder to the ground. So I want to know what this side is. So what would that be? Where's our A, B, and C? Well, we have a right angle. Okay, so our hypotenuse is the longest one, so that has to be C. So here we go with A and B. So that drawing is really, really important. Okay, so go ahead and we can get this solved out. So we have A squared, and A is actually 5, plus B squared. We don't know what B is, but we know what C is. It's 18. Okay, separate our workspace just like we always do. We know 5 times 5 is 25, plus B squared equals whatever 18 squared is, which is 324. Now we can start moving things around, right? So minus 25 to both sides, cross that out, and we end up with our B squared equals 324 minus 25 should put us at 299. All right, and then how do we get rid of the squared? Well, take the square root to both sides, cross that out, and we're left with B is equal to, let's do the square root of 299. Definitely an irrational number. We can see it doesn't stop and doesn't repeat, but we're rounding the nearest tenth anyway. So 17.3 because of that 9, okay? And it is in feet, okay? So B is approximately 17.3 feet, and there we go. Okay, all right, let's go ahead and take a look at number 2. A treasure map said to start at the old oak tree, walk 70 paces north. Well, north is up. Okay, then 40 paces east. East is to the right. Then dig. What is the straight line distance in paces, that's our units, from the tree to the treasure? Okay, so let's get your picture drawn first. Okay, we know that we're going 70 paces north, so I can draw my north distance. There's my 70 p for paces. Okay, then I'm going 40 paces east. Okay, so here's my 40 paces, and then dig. Okay, so we're starting at the old oak tree. So here's the tree here. And then we're going north, and then we're going 40 paces east, and then we're digging. So here's my treasure here. So tree to treasure, right? Okay. And basically they're just asking us, what's the straight line distance to the treasure? Okay. So if I just want to go from tree to treasure, let me lock this in. They're just asking, what's that distance? Well, here's my right angle. Here is my C. So we have our A, we have our B equals C. So let's go ahead and you can go ahead and solve that one out. A squared plus B squared equals C squared, and figure out what the approximate distance is. So make sure at the end here you end up with C is approximately blank paces. Okay. All right, let's go ahead and set up number 3 here, and you can give that a shot. The diagonal of Andre's rectangular TV screen is 39 inches. Let's go ahead and draw a TV together. Okay, so here's a big flat screen TV. In the olden days, they used to have antenna like this, and that's how you used to draw a TV. But now we don't really have those antennas. It's just a rectangle. Okay. So the diagonal from here to here is 39 inches, okay? The width of the TV is 34 inches, right? So we have length and width. Let's go ahead, we'll just use this as the width. Well, technically wide, how wide is it? We should probably use this as it. Okay, so we got 34 inches. What's the measurement of the height, okay? And so our height is here. What do you want to call these things? We got A, B, and C. We definitely have a right angle triangle or right triangle. So go ahead and you can officially label your pieces here. So we have A, we have a B, and we have a C. B you could just keep h if you want, and then figure out what is that height of the screen. Okay, so we need an official answer at the end. The height is, and we can say approximately blank inches. Okay, and then your last one is this volume one. So the volume of the cone below, this is not a cone, this is a square pyramid. So the volume of the square pyramid is what we want to be finding, not the cone. And it gives you 1/3 pi r squared times h. So let's double check that. Anytime you have weird stuff, you want to double check. Volume of square pyramid. So let's see what it is. Okay. So how do you find the volume of a square pyramid? It says the base of the area of the base, okay, which is a square, times the height, and then we divide it by 3. Okay, so is that accurate? Yep. Okay. No, it's not, because a cone is different. So we're not doing this. Okay. Volume is going to equal big B times the height, and all of that divided by 3 or times 1/3. Okay. So 3 of those square pyramids fit into a rectangular prism. So let's go ahead and solve this out. Find the volume of the square pyramid using this formula that I gave you, not the other one. Okay, so here we go. Let's go ahead and find the area of the base. Okay, so the area of the base is... this is interesting what they're having you do here. We already know the area of the base is length times width, which would be 16 squared, or 16 times 16. And then, here we go. This is why we're running into problems. And then we need to multiply that by the height, right? Okay. And the problem is with this is that we don't know how tall the pyramid is from here to the bottom. Okay. So you're going to have to figure out how to find that. Okay. So let's look at what we do know. I'm going to go ahead and draw this picture. Okay. If I draw this straight out, okay, and we draw this down, you can sort of see that triangle inside. Okay. So we know some different pieces here, right? Okay. We know the diagonal. So if I sort of pull this out here a little bit, we can look at it a little bit differently. Okay. We know the diagonal is 17, if I could write this correctly, 17 inches. Okay. Do you know what the distance is from here to here, from the middle of our square to the outside of our square? Well, we do. We know the whole distance is 16, right? So half of that from the middle to the outside has to be 8. So now we know our two sides. We just don't know that height, right? And that's what we want to be finding, is the height of our pyramid. Okay. And so let's go ahead and look at what we know. Here's my right angle, right? So I know the hypotenuse, or in this case, C. So here's A, here's B, here's C. So let's go ahead and solve this out so we can figure out our height. Okay. So 8 squared plus B squared, or in this case, we could say H squared, equals C squared, which is 17. So let's go ahead and solve this out. Separate our workspace like we always do. 64 plus H squared equals whatever 17 squared is. Oops, sorry, me. 17 squared, there we go, which is 289. Now we can start moving things around. So let's subtract 64 on both sides. And we're left with H squared, okay, equals 289 minus 64, which is 225. We've come across that one before. Let's take the square root of both sides to get rid of that exponent. And we're left with a height of exactly, what is it? Is it 15? I forget. Square root of 225. Yep, 15. Good memory, me. okay, and that is inches. So by using the Pythagorean theorem, we figured out the height of our pyramid. So now we can plug in that height up here, okay? So we have big B, okay, and remember big B is area of the base, okay, times the height, and now we know the height is 15, okay, and all of that divided by 3, okay, or multiplied by 1/3. So here's our volume. So let's go ahead and just type all of this in. So what is the volume? Here we go, 16 times 16 times 16, and we take that whole thing. I'm going to go ahead and put it in parentheses. And we take the whole thing and we divide it into a third. Okay, so what is the actual volume? The volume, round to the nearest tenth, is 1,365. It's 0.3. We actually know that's 1/3, so we might as well just put 1/3. Okay, because I'm pretty sure 1/3 is 0.3. Yep, it is. So we might as well use that since we know the fraction for that. And that is inches, and it's volume. So what are we going to do? Cubed. Okay, and there you go. There's our volume of this figure. Okay, all right, that is it. Go ahead and finish 2 and 3 on your own, and let me know if you have any questions.